Hi, all. Thanks for tuning in for another episode of 5 Minute Fun. Today, we're going to be talking about molecular compounds. And so, to do so, we need to look at our periodic table. Last time we were looking at ionic compounds, we said that ionic compounds would be the combination of a metal, which is on this side of the periodic table, with a non-metal. And today, when we are looking at molecular compounds, we will be combining two nonmetals together. Now, what's worth noting is that molecular compounds do not need two different ions to come together. So, molecular compounds, and the other name, if I could spell, that would be great. The other name for a molecular compound is a covalent compound. And what they do not need is they do not need ions. Instead, they just need two nonmetals to come together. And they will be sharing their electrons. They won't actually be giving up any of their electrons or receiving any electrons. They're just going to be sharing them back and forth. And so, a really common example of a molecular compound would be something like H2O. You know that as water, but the actual chemical formula name of this is dihydrogen monoxide. That's the actual chemical name of what water represents. So let's break that down a little bit. The rules for naming molecular compounds is pretty straightforward. Um, what we have is we have a bunch of prefixes that describe how many of each atom there are. So for one, that would be mono. For two, that would be di. For three, that would be tri. Four is tetra, like tetris, tetra, tri. Five is penta. Six is hexa. You can think of that like a hexagon. Seven is hepta. Eight is octa, like an octagon. Nine is nona. And 10 is deca. So instead of using ion names to describe how many of each atom and what type of atoms we're talking about, instead we're going to use these prefixes. And a prefix means that it goes before the actual word that it's describing. So if we look at dihydrogen monoxide, you can see that we have dihydrogen. In other words, we have two hydrogens. And this monoxide tells me that, in fact, we have one oxygen. And so that describes the entire word. Now, the only other rules that we need to say here is that the first element keeps its name. Another common example that you've probably heard of would be CO2. And you would know this as the thing that you breathe out or respire. This is carbon dioxide. So the first element named keeps its name. The second element listed or named, listed, it has its ending changed. It has its ending changed to IDE. So this is oxygen, but we are changing it to oxide. And the same could be said for our water here. The ending is changed to oxide. And the other thing that we're doing then is we're saying we name the first element, it keeps its name. The second element has its ending changed to IDE. And then in front of each of the elements, we add our di, tri, tetra, penta, hepta, hexa, so on and so forth. Now, the one exception to this rule, and you'll notice that this occurs in carbon dioxide, is that we do not include mono in front of carbon. So the first element keeps its name and can have any prefix except mono. The second element listed can have mono, as we see in our water example here, dihydrogen monoxide, but the first element cannot be monocarbon dioxide. Instead, it's just carbon dioxide. It doesn't get that mono title. Then, in terms of if we were actually translating it from word into the actual chemical formula, let's say that we got an example that was trinitrogen, and I've been using oxygen a lot. Let's use pentachloride. The first thing that we would do when analyzing this is we would say, okay, are we dealing with a molecular or an ionic compound? And immediately, as soon as I see these little prefixes, I would say, okay, this has to be a molecular compound. And so because I know it's a molecular compound, then all I have to do is say nitrogen has the chemical symbol of N, chloride has the chemical symbol of Cl. How many nitrogens do I have? I have 3 of them. How many chlorides do I have? I have 5 of them. So that's a really quick tutorial on how to do molecular compounds. Hopefully that was clear. Let me know in the comments if you have any questions. Peace.